Yeah, let's talk about some trig integrals here. And, you know, the regular trig integrals, sine, integral of sine, integral of cosine, we want to stretch ourselves beyond that and do, basically what we're going to be thinking of here is powers of sine and cosine, and we'll get to secant and tangent as well. We'll talk about that as well. So that's the idea here. Powers of sine and cosine and others as well. First, though, let me talk about the trig identities, some of the trig identities. You know, our most famous one would be sine squared plus cosine squared is 1. Okay? Well, that one's helpful to us, but in the alternative form, solve this for sine squared. Sine squared would be what based on that? 1 minus cosine squared, or vice versa? Yeah. Cosine squared would be 1 minus sine squared. Okay. So those are going to be important forms to us, but they just come from the identity there, right? Subtract whatever over. The other, the double angles will also be helpful, but in an alternative form. The cosine double angles, matter of fact. Cosine double angles, and I think I do have these on the sheet there to help you remember, but the cosine of 2x, the double angle, is, one form of it is 2 cosine squared x minus 1. Remember that? Way back in the day. Okay, well, the form that will be helpful in integrals is, again, solve for cosine squared. Solve that for cosine squared, and so I can say add 1, it'll be cosine 2x equals 2 cosine squared, then divide by 2, and so I get cosine squared equals that. Now, usually the way we write it is 1/2 cosine 2x plus 1. Okay? So this will be a helpful thing. And what we're going to do, depending on the situation, is if I have a sine squared, sometimes it's helpful to replace it by 1 minus cosine squared. Sometimes if I have a cosine squared, it's helpful to replace it by 1 minus sine squared. Sometimes, though, it's going to be helpful, though, to go cosine squared equals 1/2 cosine of 2x plus 1. You see what I'm saying? I'm going to be replacing these by these. It came, where did it come from? Yeah, I think you can, I think it actually comes from the sum, cosine of sums. You know what I'm saying? And then I think you can get the others. The cosine, you remember these, cosine of x plus y? You can establish what the cosine of a sum is. I think the original one comes out of that. I don't know. It's cosine, cosine, sine, sine, or something, but yeah. All right. Now, there is a form from the double angle for sine squared. Remember, we can also write cosine of 2x in terms of a sine, and that does come. You plug in 1 minus sine squared for cosine squared there, and you wind up getting, I think it goes the other way, it's 1 minus 2 sine squared. And so long story short here, if you solve for sine squared there, you get 1/2, it would be the cosine of 2x minus 1. And so these will be the double angle identities I referred to. Yes. On that sheet that I gave you, does it have these exact forms, or does it just have the double angle? Let me see it. Yeah. So on the handout that I gave you, that you have there, it has these, the ones that we'll utilize. So if you forget, I will give those to you provide those to you on the test. Okay, but anyway, these four, keep those in mind. And then a couple more will come too. Tangent, we'll do tangent and secant. One's here. Okay. Now to the trig integrals. These, the designation, I guess we might put it, is these will be trig integrals with an odd-powered sine or cosine. So I'm talking integral with an odd-powered sine or cosine. Because the deal is, depending on what you got, different ways of working it. And if it has an odd-powered sine or cosine, this is how you work it. Here's one, for example. Cosine to the fourth x, sine cubed x dx. If I have the integral of cosine to the fourth sine cubed dx, okay? You see there I have an odd-powered sine function, right? Right there. So that's why it fits into this category. Here's what I do if I have such an odd-powered trig function. What I'm going to do is I'm going to hold out one of the signs. Here's what I mean by that. I'm going to break this up. I'm going to say cosine to the fourth x times, and if I break out a sine of x, it would be sine squared x times sine of x dx, and I'm going to write the sine x over there with the dx. You'll see why here in just a second. So I'm going to hold out one of those, and then I'm going to convert this over to cosine. Convert the sine, convert the remaining sines, the sine squared here in this case, convert that over to sines. And how would I do that? I mean cosines. Using 1 minus cosine squared, right? Pythagorean identity. So cosine to the fourth x, so that becomes 1 minus cosine squared x, and then I have times sine of x dx. Well, it doesn't maybe look like I've done much of anything, but look at this. If I distribute then the cosine to the fourth x, multiply that inside there, cosine to the fourth x times 1 is cosine to the fourth x. Cosine to the fourth x times minus the cosine squared x, what does that give you? Cosine to sixth x? Right? You're just adding, you just add the exponents like, okay? Times then it'd be sine of x dx. Here's why I do this. Turns out now, if I go ahead then and use u substitution, guess what I'm going to let u be? Yep. Just u substitution. Let u be the cosine of x. Du then is negative sine of x dx. And so du would be minus, du over minus sine of x would be dx. Look at that. That's going to cancel out like that, yes. So now I have the integral of u to the fourth minus u to the sixth, right? Because cosine is u. So this is just u to the fourth. That's u to the sixth. Then I have sine of x. Then d of x, dx is minus du over, or du over minus sine of x. Yes, and that's why we held the sine of x back. Because that's what's going to happen. They're going to cancel. Genius, yes. We'll do that. Yes. We're going to do it just the reverse, yes. Now, I do have a minus 1 here, so I'm going to go ahead and say that's minus u to the fourth plus u to the sixth. You with me on that? Du. Go ahead and factor in that minus 1, or multiply that in. But now what do I do? That's just power rule, yeah. That's just antiderivative power rule. That would be negative 1/5 u to the fifth. This would be 1/7 u to the seventh plus c. All it needs then to go back is to the x counterpart. Well, u is cosine of x, so this would be minus 1/5. That would be cosine to the 5th x. And this would be plus 1/7 cosine to the 7th x. Okay? Not too bad, right? All right, well, let's take a look. Yeah, let's look at the another one. And this one will be easy to decide. This is cosine cubed x dx. Well, there's only one alternative here, but it is odd powered. Now, if that was an even power, we'll talk about that. But this is, I do have an odd power. So the kicker is you've got to have an odd power for this to work, for this substitution thing here to work. Okay? But I do have an odd power, so what am I do? Hold one out. So I'm going to hold out a cosine, so that'll make it cosine squared cosine dx. Right? Hold that out, and then what do? Change the cosine squared to sine squared. So what is cosine squared in terms of sine squared? Cosine squared is 1 minus sine squared. Okay? Now what I do? That's when I use u substitution. The u here is going to be the sine, right? So du would be the cosine of x dx. So du over cosine is my dx. Other ways you can think of that, but here's what I've got then. So there I have then the integral of 1 minus u squared cosine x, but dx is du over cosine. Aha. Cancel. So I just have 1 minus u squared, don't I? That's just simple antiderivatives, right? Antiderivative of 1 is u. Antiderivative of u squared is 1/3 u cubed plus c. Go back to what u is. U is sine of x, so it would be sine of x minus 1/3 sine cubed x plus c. Not too bad so far, right? Not so far. Yeah, actually, we like to see these odd-powered ones. Let's do another. Just make it always be an odd power. Well, can't usually get by with that, but here's another one. One more of these, because this is something else you might have to do. Sine to the 5th x cosine squared x dx. Let me just ask you this before we go. What if they were both odd powered? Take your pick, yeah. Just take your pick. Probably go with the lower one b. Like if this was sine to the 5th sine cubed, sine to the 5th cosine cubed, probably go with the, hold back the cosine, because it'll be easier as you'll see. Okay, but anyway. No, you just have to do it once. You just have to do it once. All right, so yeah, here we've got again the sine, so I'm going to hold back a sine, so that would be sine to the 4th x cosine squared. You can rearrange them however you want to, but I'm going to put the sine of x dx over here because that's where it will cancel out eventually anyway. Okay? Now, this is why I mentioned that's sine to the 4th. The trig identity is sine squared. Well, yeah, here's what I'm thinking. Sine to the 4th, isn't that sine squared squared? So I replace sine squared by 1 minus cosine squared, but then I have to square that. With me? Yeah, just, I mean, if it was sine to the 6th, I'd do sine squared cubed, right? All right. So that just means what is, so, you know, pull that out, 1 minus cosine squared twice, however you want to. So it'd be, what, 1 minus cosine squared minus cosine, isn't that minus 2 cosine squared and then plus cosine to the fourth. Wouldn't that be what I get when I square that all out? Is that okay? This becomes that, which becomes that. Is that okay? Now what? Well, this is one where then we have to have the step. Well, now we need to multiply in the cosine squared here. So this then becomes cosine squared times 1 is cosine squared. Cosine squared times minus 2 cosine squared. Minus 2 cosine to the fourth x. And then 2 cosine squared times cosine to the fourth, that's cosine sixth. And then sine of x dx. And so, what do I do now? U substitution, yeah. Now I'm ready to say u is the cosine, du is minus the sine. So du over minus sine is dx. So I get the integral u squared minus 2u to the fourth plus u to the sixth sine of x du over minus sine of x I'm in real good shape here, aren't I? Because the sine of x cancels. So I have integral there. I do have a minus 1. Don't forget about that. Don't leave that off. So this would be minus u squared plus 2u to the fourth minus u to the sixth. Go ahead and take that out. Or in there. Now it's just power rule, right? Minus 1/3 u to the third plus 2/5 u to the fifth minus 1/7 u to the seventh plus c. But then u is a cosine, so it's minus 1/3 cosine cubed 2/5 cosine to the fifth minus 1/7 cosine to the seventh plus c. Just gets longer the higher powers you get. Okay?